Vector velocity of the plane, that's the first one.
All right. Vectors. Vectors are tough. First thing to know about vectors is that they have direction and magnitude. That's the difference between a vector and a scalar. So the plane, that's its magnitude. Whoops, hold on. Let me take a picture of this so I can draw on it. So that's its magnitude. That's its bearing.
What is? Oh, okay. I see it now.
If we wanted to draw, I'll draw it separately here. So its bearing is 30 degrees south of east. Well, that's east. So 30 degrees south of east would be like that.
Mm-hmm.
And the size of that vector is 600. A tailwind in the direction 45 degrees south of east is blowing with a velocity of 40. Let me change colors. So here's the tailwind. And it's blowing at 40 miles or 40 km. Just say 40. Doesn't look like they're changing the units up on us here. We can kind of ignore the units for the moment. And the question is what? Find the resultant vector?
Find the velocity vector of the plane.
Yeah, in other words, obviously if there was no wind, the plane would fly at 600 kilometers per hour at 30 degrees south of east. But with a wind, it's going to affect the plane. And if we want to combine those two vectors, the best way to deal with vectors is to really break down each vector into its components. Add the components together, put them back together, and you have a resultant vector. So let's take the, I'm not sure. I can only guess that that's what they've tried to teach you to do. Okay, so if we're looking at that vector there, what is the horizontal velocity of that vector?
Of which one?
The pink one.
Is it just 600?
No, that's the vector velocity. But the horizontal velocity, if I complete the triangle, is going to be x. And we know that the cosine of x, the cosine of 30 degrees equals x over 600. So x has to equal to 600 times the cosine of 30 degrees, which is root 3 over 2. You have your calculator?
Yeah.
What's the horizontal component of that vector? It'd be about 5-something. 500.
519.
What is it?
It's 519.6.
Okay. And let's get the vertical, because there's a downward velocity also. Well, that's going to be the sine of 30 degrees equals x. So that's just going to be 300.
Is it?
I think. Let's see. Sine of 30 degrees equals the opposite over 600. Sine of 30 degrees is 1/2, so it's going to be 1/2 times 600. Okay? So here's what we've got. The plane, the x component of the plane equals 519.6. the y component of the plane equals 300. Now let's do the same thing with the wind. What is the x component of the wind?
Cosine of 40 degrees is x over, what, let's see, what is the wind? Okay, x over 40.
It'd be the cosine of 40 degrees times
x over 40.
Right? Because this is the triangle I'm dealing with on the wind.
Yeah.
And that's a 40-degree angle. Whoops.
It's 45.
45. So it's actually the cosine of 45 equals x over 40. And the sine of 45 also equals x over 40. So what is 40 times the sine of 45?
Times the sine or cosine?
Well, either one of them is actually the same. Sine of 45 is root 2 over 2. Cosine of 45 is root 2 over 2. So it's the same number.
28.28.
All right. And it's in the same direction. It's positive. So what we have here is the wind is assisting the x direction, and it's also assisting the y direction. So what is the x component of combined?
I'm not sure. What, just adding both of them together?
That's always what you do. Whenever you have a bunch of vectors, you figure out the x and y component of each vector, and then you add them together. Now, sometimes the vectors, the wind could be going the other way, in which case you would subtract the x component. But in this case, the wind is going in the same direction easterly, and it's going in the same direction southerly. So it's helping that plane. It's going to make it go faster.
I got 547.9.
And the y component.
Just 328.28.
Now, let me erase some stuff here to make some room. Now we go the other direction. Okay, in other words, now we have an x component of 547.9 and a y component of 328.3. And what we want is the resultant vector. Well, that's this vector. Which is the hypotenuse of that triangle. So if you want to know what the resultant vector is, you can do a couple of things. There's a couple of things at this point in time that we need to know.
Can't we do use the Pythagorean theorem?
You can do that. That gives you the magnitude. Go ahead if you want to do that, but there might be an easier way. Notice this triangle that I have drawn here. That's 328. Let's just round everything off. Okay, let's go ahead and figure out the hypotenuse. Go ahead and figure that out.
I got 638.7.
So that's going to be the speed of the airplane. It was only going 600, but the wind's helping it, so it's going a little faster. But I also need this angle because the airplane had a bearing of 30 degrees and the wind was blowing it more south. So you have to use a trig function now to figure out what this theta is. What's the trig function?
It's the inverse of one of them, right?
And you can use actually any trig function because you have all three sides of that triangle. It's a right triangle. So you can use any one you want. Use sine, cosine, or tangent.
Just do sine.
I
don't remember how to do this part.
Okay.
It's been a while.
Sine of theta, always start with your trig function, is equal to what? Opposite over hypotenuse. Opposite is 328.
328 over 638.
Round it off, 639. Now, to get theta, what do? Remember what trig is all about. You take trig functions of angles to get ratios. You take inverse trig functions of ratios to get angles. So we're trying to figure out what this angle is. So I'm going to take the inverse sine of that ratio, 328 over 639. Make sure your calculator is set on degrees and figure out what that is.
I got 30.9.
Now let's see if that makes any sense. Plane had a bearing of 30 degrees. The wind was pushing it further south. 30.9 is bigger than 30. That sounds actually about right because the wind wasn't very big. The wind was only a 40-mile-an-hour wind. The plane's going 600 or 40 kilometer an hour, and the plane's going 600. So you wouldn't expect it to blow it off course that much. So that is a ballpark answer. In other words, had you come up with 29, I would have said no. Had you come up with 46, I would have said no. The answer has to be somewhere between 30 and 45 degrees. Okay? And that, in a nutshell, is how you do these problems. Now, notice that I didn't necessarily have to use the Pythagorean theorem here. I could have used a trig function to solve for theta. I could have said the tangent of theta is 328 over 547. That would have given me 30.9 degrees. And then I could have said the sine of 30.9 is 328 over x, and I could have solved for that hypotenuse. So if you want to rely strictly on trig functions, you can here. You don't need to go to the Pythagorean theorem. Not that that's particularly tough, but given the numbers we're dealing with here, the Pythagorean theorem could be a little bit intimidating. You know what I mean? It's just easy to make a mistake if just because we're dealing with three-digit numbers here. Now, I can't quite read this writing. Is that in regards to question 10, or was that in regards to the previous question?
It just says velocity vector of the wind. It's for 10.
Did we answer everything we need to on 10?
No. There's 10A through E.
What's the rest?
The second one is find the velocity vector of the wind.
Okay. Well, they gave us the velocity vector of the wind. It's 40 miles an hour at a direction of 45 degrees south of east. And we did break it up into its two components. Maybe that's what they meant.
Oh, I guess we did do it all then.
Well, they gave it to us. They gave us the velocity vector of the wind. They gave us the velocity vector of the plane. Well, I should say the instruments on the plane. In other words, the instruments on the plane, as far as the pilot is concerned, he's going 600 kilometers per hour at a bearing of 30 degrees south of east. That's what his instruments are set on. But his instruments measure his direction with regards to the air. If you want to know what his velocity and direction are with regards to the ground, then you have to add the wind in, and that's what we just figured out. He is going at 638 kilometers per hour with regards to the ground at a bearing of 30.9 degrees south of east. Now, I rounded off a lot of these, so that answer might be off by a little bit, round off error. I get a little irritated with them sometimes when they give us these decimals out to two places, like, what is the point of that? You know, what else do they want to know about this problem? I can't see their question.
Yeah, that's it actually. That's it, because what we answered, what we got from the first one answered the rest of them pretty much.
I think so. I think we've answered everything there is to know about this problem.
Because the velocity vector, the wind it gave us for the plane, I guess it gave us. We just had to find the actual one.
Exactly. What they want is the velocity vector relative to the ground. And the wind is relative to the ground, and the plane is actually not. When you set the instruments on the plane, it's not relative to the ground. It's relative to the air. Because you don't know exactly what the wind's going to do as you fly the plane. You set the bearing at 600 kilometers per hour at 30 degrees south of east, and you head out. And then the wind comes along, and it starts helping things or hurting things. And since it changes your direction a little bit, the wind causes you to actually go at 31 degrees south of east. You have to adjust for that. So the pilot who's piloting the plane has to steer it a little bit to the left if he wants to get to his destination.
Because he's going 600 kilometers an hour.
Exactly 30 degrees south of east, but he's not going that direction. He's going 31 degrees south of east.
Which I guess is a big deal at 600 kilometers.
Well, it's a big deal if he wants to. It's a big deal for every pilot. There are two parameters when you're flying an airplane, and that's the speed you set the airplane on and the direction, and then you got to combine it with the wind. So every single airplane flight every day has to take these two variables into consideration to get where they want to go and to know when they're going to get there. In other words, this plane is going to be ahead of schedule because the schedule is counting on it going 600 kilometers per hour, but the wind is helping, causing it to go 638 kilometers per hour. So that's why some planes get on ahead of schedule and some late. Sam, what else you got? We got more time.
Let's see. I guess I got a quick one.
Okay.
I'm not sure if I did this right. The next one is just express, and then it's AB as a positional vector V of XY, and A is 5, 12. And B is -1, -5.
So 5, 12 is A?
Negative. Oh no, it's positive. And then B is -1, -5.
And what do they want you to do with these two vectors?
Express AB with the arrow over the top as a positional vector V equals X, Y. So do you just multiply it to get the, like you multiply the 5?
I think, I'm not 100% sure I understand the question, but I believe I understand what they're looking for. Let's talk about this for a moment. That vector right there is identical to that vector right there.
Mm-hmm.
In other words, the position in space does not matter. What matters is its direction the same and is its magnitude the same?
Mm-hmm.
Therefore, when you come up with a vector that is between 2 points, let me graph this one, make it a little bit more understandable. I may not even be understanding it properly, but I'm going to call that the 512 vector. Okay. And I'm going to call -1, -5. That's the B vector. Or are they talking about a vector that goes from one of these points to another point?
No, it just says express AB as a positional vector. So I guess I'm not entirely too sure what they're asking either.
Okay. I still think I know what they're asking. Let me explain it a little bit better. I didn't start it off very good, though. If I label those 2 points, there's 512,
Mm-hmm.
there's -1, -5.
Mm-hmm.
So that's the vector between those 2 points. So if
Uh-huh.
I'm talking about AB, I'm talking about that vector.
Mm-hmm.
And I believe what they're asking is give the vector that starts at the origin, what vector would be identical with this vector, only it would start at the origin, would go in exactly the same direction, and have the same magnitude. And the way you do it is you just subtract it. In other words, I could say that if I go to 6.17, in other words, if I go from 0, 0 to 6, 17, I have the same vector, only this blue vector is called a positional vector, I believe, meaning that one end of it is the origin. The original vector that they were talking about was just two points, okay?
Mm-hmm.
And it's easier to talk about a vector as 1 point. So if I want to talk about a vector, I would rather say it's 6, 17 than say the vector that goes between the points 5, 12 and -1, -5.
Okay.
This single definition of that vector is shorter, as you can see. It's only 2 numbers. It's not 4 numbers. And
Mm-hmm.
this presumes that one end of the vector is 0, 0. But remember, the blue vector is the identical vector as the pink one. It's the same magnitude
It's
and
just in a different position.
exactly the same direction. Is all I did was move this point right here up to the origin and then continue on. Now
Okay.
that's what I think they were asking. But this is a key part of vectors, is taking 2 points that make up a vector in your xy coordinate plane and turning it into a vector that can be defined by just 2 points, not 4 points. And you do it by taking that and subtracting that, and then you take that and subtract that. That's how I got the 6, 17.
Okay.
Okay? I hope that's what they meant.
Hmm.
I don't know. Vectors is a tough subject for me. Always has been, always will be. It's like my brain has kind of a block about vectors. Vectors are everywhere in life. They're extremely important. There's nothing bad about them. It's just that they confuse a lot of people. And me being
Yeah.
one of them, there can be some really interesting vector problems that are really, really hard. Um,
Hmm.
but the ones you've given me tonight aren't those. These are relatively straightforward ones, assuming I interpreted the second one correctly.
Hmm.
And if you want the magnitude of the vector, this vector I've got over here, you take the square root
No,
of 6 squared plus 17
it's
squared. That's the magnitude of it.
6 squared plus 17.
The square
Yep.
root of that. In other words, the blue
Pythagorean theorem.
triangle, its dimensions are 6,
17.
17. So the hypotenuse, or the magnitude of the vector, is going to apply the Pythagorean theorem, and you can also figure out the angles and everything else using trig. So that's why you have to have trig before they can teach you vectors, is because there's that angle there, and it's usually an inverse tangent function.
Hmm.
Sam, you got any other questions for tonight?
No, that's it.
Okay. Have a good one. I'll talk to you next time.
You too. Thanks.
Bye bye.